Hey everybody, today we're going to do a basic CCT video. I've had a lot of comments here to ask what the basic CCT is. So if you've been messing with CCT for a while, this video isn't for you. If you've been doing it for a long time, go watch my air handler sequence from hell video. That'll more advanced. But today let's focus on basic. So I have CCT already open here. I'm currently at the latest and greatest, version 15. To find out what version of CCT you're running, go to your Help About tool and tool version 15 right here. So as of today, it's the latest and greatest. So the highest I can go up to firmware wise is 10.6. Okay. So to change firmware settings, I could go to settings, release mode, and I have three options here. I have 10.6, 10.5, and 10.2. This is important because any of the older stuff has to be done in 10.2. They can't upgrade to 10.5 or 10.6. So we're talking about anything that starts with an FX, FXPCG, FXPCV. If it starts with an FX and a P, you're going to have to do it in 10.2. Okay? 10.5 and 10.6 are for the F4 controllers. And I could show you that here. So we're still on the blank page here. You could go over to Define Hardware. And this is going to show you what you're licensed for. And it's going to show you the build number. So as you see here, 10.4 is going to be the 9, or 10.5, sorry. 10.5 is going to be the 9 numbers. 10.6 is going to be the 10 numbers. And then 10.2 is going to be the 6 right here. See, FXPCA 6. There are a couple of exceptions. Yes, we got this 2513, and there'll be some other exceptions down here. 4911, that's the IP controller. The 1930, again, that's an IP controller that's been discontinued as of this video. So there are a few exceptions, but overall, we can't do PCVs or PCGs in anything other than firmware 6.2. That's going to be release mode 10.2. Okay, so now that we know what we're licensed for, we could go and set up a controller. So from scratch, we can go over there, File, hit the New. Now, what do we want to program, and what version do we want to program? Right now, I'm set up for 10.6. It says this right now. Now, yours might look a little different. Whenever you click into there, you might get a screen like this. I don't like that screen because if I click on the wrong thing, it's going to send me to a different version. So I want to make sure I'm always at 10.2. So I click this do not show this dialog in the feature and hit OK. And then every time you open up the file new, you're going to get this window. And if you want to change it, you're going to have to hit change release mode here, or before you open this, come up here to settings, change release mode. So let's do, you said basic, so let's just do a basic VAV box. Okay. So we have to give the system a name. I suggest naming it not VAV01, VAV02, VAV03, right? This is a generic system name. So say your VAV has SCR heat, you would name it VAV underscore SCR. That way it gives it kind of a description, right? If it has two-stage heat, VAV 2 STG HTG. There you go. Okay. So we'll go with two-stage heat. We're going to choose VAV unit, choose single duct, and I'm in the United States, so I use Imperial. So we hit OK. Now it's just a matter of answering questions. It's just a matter of going down the list, checking what is on the equipment. Okay, so we want to use the integrated damper. Yes, okay. Our controller has an integrated damper. We want to use that integrated damper. Okay, exhaust damper actuator. No, don't have that. Box fan. Yeah, we're going to say it has a box fan. This piece of equipment, we're going to say I have a box fan. Now, you got three options here for a box fan. You got a series fan, a series fan variable speed, and a parallel fan. Now, hopefully you know the difference between the three of those, but let's talk. So, series and parallel, series is going to run in cooling mode and heating mode, okay? So, when the unit becomes occupied, that fan is going to kick on. So it helps pull air from the air handler. Okay, sometimes you need that to get into certain spots. Okay, parallel, that's usually the ones I see down here. I'm in Texas, so I see a lot more parallel here. Parallel temperature based fans. Okay, so I'm going to choose a parallel temperature based fan. If you have a series, you just click the series. If you have a variable speed series, you click the variable speed. Okay. And then fan status, if we have a fan status, we can check it. If not, we don't check it. It's that easy. We said two-stage heat, so we're going to go down. Our next box is our heating coils. If we didn't have any, we'd uncheck that, but we said two-stage heat, so we're going to choose that. Okay. Obviously, if we had hot water, we would tell it what kind of actuator we had. And if we had SCR heat, we would tell it SCR. And if that needed a binary output, a closed contact to turn it on, we'd click that little button. But we're going to go with two-stage heat, supplemental heating. This is like baseboard heating for people up north. It's for another inline duct heater, any kind of supplemental heating. We can click this and choose what it is. But in this case, we're just not going to go with it. We have some optional equipment here. Okay, lighting and a calibrated solenoid valve. So a calibrated solenoid valve is for putting these Johnson Control VAV units in a lab situation or something where you want constant flow all the time, and this valve cannot shut down. The actuator cannot shut down to do its auto calibration, right? So these controllers have to auto calibrate every 14 days. That means that the damper is going to close off all the way, and then it's going to look at airflow, and it should say 0, and it's going to zero out the airflow, and then it's going to open up back up the damper. Okay, that's how it auto calibrates every 14 days. If we couldn't close the damper because we're in a lab or something where we cannot stop the airflow, we would put a solenoid valve on the high side of the um, velocity pressure tube, right? So we put a solenoid valve between the unit and the velocity pressure tube, which would close that high pressure all the way off, showing 0 pressure without jacking with the damper at all. The damper is just going to lock in place while it does this little calibration every 14 days, and it goes on. Not too often. I've actually never seen this. Okay, Johnson has it in here, but I've never dealt with this. The next one down, we got sensors. We got a supply air and a discharge air. Now you got to be careful which one you check here. Okay, in Johnson terms, supply means before the VAV. It's what's getting supplied to the VAV. So supply is before the heat strips, okay? So this is your temperature coming from the air handler to your VAV. Before it gets to the VAV is supply, okay? Discharge is after the VAV. It's after the heating coil. So this is what your unit is actually putting out. Okay. Why do you need supply? Well, you see, use for morning warm up. Okay. What's morning warm up? Well, in the mornings, it's more cost effective to heat the whole air handler, right? And just do heat on the whole air handler up to 90 degrees or whatever, and open all the boxes in the building and use that hot air to warm up the whole building rather than have every single VAV using its electric heat strips to warm up each individual space. You see, there's a cost savings there. Now, when it's only onesies and twosie VAVs warming up the space, then it's cheaper to just use electric strips in the VAVs. But when the whole building is cold, it's cheaper, more cost effective to use actual air handler heating. So that's why you use supply air in morning warm up. Okay, so we got discharge air temperature. Now we're down to our zone. What kind of thermostat do we have? Do we not have a thermostat at all? Hey, I don't know, right? It's just a sensor, maybe. We could do blank wall stats, right? But if we have set point adjust, if we have an adjustment, common set point adjust is where you have an LCD screen, right? And it says 71 degrees, 72 degrees, 73 degrees, right? It gives you a range. It's an absolute range on what the temperature is, right? It is what you set it. Warm cool adjust, that's a relative range, right? That's +1 degree, +2 degrees, +3 degrees, or -1 degrees, -2 degrees, -3 degrees. Whatever range you set in there, you have a network set point of, let's just say 70 degrees, and you give the customer an option up and down 5 degrees, right? The customer usually does not know what the actual set point is. All they know is, do I want it warmer or cooler? I want it warmer. I'm going to put it plus. All the way the plus will go. Therefore, their space gets warmer. I want it cooler. They're going to set it negative all the way as far as it go. Therefore, the space gets cooler. So that's warm cool adjust. That's common set point. Then we got this temp out aux support, right? So if we want some temporary aux support, we click that button. Humidity, right? Occupancy, okay? And CO2 sensor. And right here, we have another button used for minimum flow reset, right? We can just have a CO2 sensor or we can have it doing something, right? I'm not going to click any of those. I'll click humidity, okay? Because that's kind of common. Temperature, humidity, at least where I'm from. Next list we got is miscellaneous, okay? Energy hold off switch, unit enable switch, okay? Those are just additional points that we can put in. Into compatibility options. If I click this, this does not automatically turn this controller into. There's other steps that we have to do to make that happen. If you don't know what N2 is, don't click it because it's taking it from BACnet and turning it into N2. But there's other steps involved if we're going there. So we have a BACnet controller. Not even going to worry about it. We go to the next page, and now we got more questions. Box reheat coil control. Are we doing zone control or are we doing discharge control? It will not let me do discharge control, right? Because I can't do discharge air control on two-stage heating. Staged heating, it just doesn't work. But if I choose package, now I can. So see, I could do discharge air on SCR, I can do discharge air on hot water, but I can't do it on staged heating. It just doesn't make sense, right? Staged heating is stage one is either on or off. There's no halfway in between. Stage two is either on or off. There's no in between. The in between is stage two is stage one, right? If we're not getting enough heat in stage one, we're gonna go to stage two. Okay, we got zone control, heating flow reset. We can click that and it'll reset the flow of the box in heating mode. Usually don't need that, right? We got always occupied and schedule occupied. Well, be careful here because as soon as we choose always occupied, it's going to take the whole scheduling thing out. In 10 years down the line, 3 years down the line, when the customer goes, oh, yeah, well, we do want to occupy this. Well, now you have to rewrite all the logic. It's it's easier just to use schedule occupied and don't put a schedule in here. That way it just stays occupied all the time. If the customer says, "Oh, we're going to be occupied all the time," just leave it in there for future work. So save you. Heating priority. Again, if we had supplemental heating, we could choose which one we want first. And finally, here's our optional features. Okay. We got some smoke control, right? This is basic video, so we're not even going to get into smoke control. Unit enable. Okay, this is a network point. It's fine. Power fail restart logic. This slowly restarts the controller after the power goes off. Network warm up. Cooldown support. Sure, we'll leave it in there. Color winner compensation shift. Sure, we'll leave it the way it is. And then whenever we hit finish, it's going to build all our programming for us. Boom, done. Okay, not quite yet, but we're very close to being done here, right? Got to do a couple of things. So we got to come up here to define hardware. We have to look at our field device, okay? F4 CVM 3050 controller. That's the VAV controller I want to use. So that's perfect. Now I have to go to point assignment. As soon as I go to a point assignment, it actually it assigned everything a point. I have to make sure this is right. I don't like this. Look at this. Heating stage one, fan, heating stage two. That doesn't make sense to me. So I'm going to make it fan, heating stage one, heating stage two. Just like that. All I did was just move it around, drag and drop. Okay. If all your points are full, you click on one and you put it over here, and then you're able to move stuff around. And then when you're done, click it back. Okay. Next thing we have to do is network settings. Now this is where you want to change the name. So change the name to match your drawings. VA1 underscore 01. Boom. So this is the actual VAV that I want to download. Now, device address. This has to match your device address on your controller. You set that now by turn dials, okay? It used to be binary switches, now it's turn dials. So I'm at address 4, cool. Johnson controls, you can't go below address 4. Watch what happens when I change this to a 3. It won't let me. Device address is invalid. Ranges from 4 to 127, okay? So it automatically puts it at 4 for me. Instance ID, this is another very important one. You can only have one unique instance number per controller on a whole building. If it's multiple buildings going up to one supervisor, then each one of those controllers and each one of those multiple buildings need to have their own instance number. Okay, so make that very unique. We're going to go 1004. Okay, and then everything else we're good on. So we can close this. Now, if we, again, skipping off a little bit of basic here, but if we had to change this controller to N2, we would come to this N2 mapping and create it. But we're not going to do that. We'll do that another time. So we're done with that. We can close it. Now we need to set our set points. Okay. Another important thing. Set points can be done down here at the bottom. So we're going to hit edit. We're going to go and find all the set points that we need to set. Okay. Nothing there. Right here, we're going to set some zone set points. So what do we need it when it's unoccupied? Cooling unoccupied. Look at our drawings. It says it needs to be 80 degrees. Not too concerned about standby, but cooling occupancy, I'm going to go ahead and change that to 72. Okay. And then everything else is good. Now here's the box size and the box flows. Okay. Cooling. What's our cooling max flow? Well, let's just say this box is 800. What's our cooling min flow? We'll leave that, well, we'll say this 250. Okay. What's our heating min flow? 350. Okay. What's our size of the box area? You can get this from just literally Googling a form. Let's see here. Let's do VAV box K factor chart. Boom, right here. Everybody see this? Where'd it go? Right here. Here's your good chart. Okay. It's going to get you very close. Okay. It might be not exact to the box manufacturer that you have, but this is going to get you super close. Here's our size. 8-inch box, 0.349, K factor of 2.24. Okay. Let's say we have a 10-inch box, 0.545, 196. So let's close this and let's go 0.545, 1.96. Okay, boom, done. That's going to get you very close enough for a tab guy to come behind you and actually be happy because all he has to do is put a little tweak in this K factor and be done, right? If it's a 10-inch box and you have the 8-inch settings in here, it's not going to work right until it's fixed, okay? And it's going to drive the tab guy crazy if that tab is coming behind you because nothing's set right. It's going to be some far out there K factor because you don't have your size of your box set right. So set the size of your box. And that should be the only things that we have to change. Apply. Boom. Now, we would load it. That would be transfer to device, save the changes. This is, do you want to save the changes to your computer? Okay. This is not saving the changes to the device. So if you want to save it to your computer, you hit yes. We're going to hit no. Now, how are we going to transfer this out to the device? Okay. We got some options here. I got supervisor pass-through. That's only an NAE. That's not a JACE. Okay. Then we have map gateway or backnet router. That's our only options on the new F4 controllers. So I would use a map gateway, and map gateways are set up. They're always going to be 192.168.1421. Now this could change depending on how you got into your map gateway, but standard out of the box, once you enable it, it's 47.808 to 65.001. Now you have to look at your network interface. That's the network interface that I would use, and then you hit next, and this would load it. I'm not hooked up to a controller, so this is not going to load. But you would just hit next, and you go through, you confirm, be done. Okay. Now, say your damper's backwards. Well, if your damper's backwards, all you gotta do is come over here to outputs, hit edit, and you would come down here to polarity and change it from normal to reverse and hit apply. Now, if you're live, that's a live change. You don't have to do anything else. If you're not live like I am, then you would have to reload the controller, transfer to device, reload the controller, boom, done. So this is a extremely basic CCT, how to program a VAV controller. Please like and subscribe. If you have any more questions, just comment below.